We'll start recording. All right, let's start with any questions. Any problems people are running into? Questions, concerns? Yes, go for it. Yeah, you can use anything you want from the math library, except if you find a way to find greatest common factor, don't use that. Write that yourself. But yeah, absolute value function, totally fine. But if not, you could write one yourself too if you really had to. Let's see, fraction x dot add n function. The syntax is confusing me. For just add or for in general for these add, subtract, multiply, divide? Because they're all kind of similar. Okay, cool. So yeah, it's very different from kind of the usual approach. But here's the idea. You're going to have like a fraction, and we'll go with yours. So you got a fraction x. Okay. And in your fraction class, you define a method. So over here, here's your class fraction. And it's got a numerator and a denominator and other stuff. And you're going to define this public method called, I'll just do multiply. And it's going to take an argument. Okay, we can call it n. And this method returns a fraction. So it's a public fraction, multiply. And the way you're going to use it is like what you wrote. You're going to say, for example, if x is a fraction and you have some fraction y, you can say x dot multiply y, and maybe you have a fraction z, and so you would say z equals x dot multiply y. All right, so this is how you use that method in that fraction class. And a way to think about this is, fraction is a class. X, y, and z are objects or instances of that class. And so since x is an instance of a fraction and mul is a method in the fraction class, x dot mul is saying call this set of code inside this object x. All right. So when you're inside multiply, you're given one fraction as an argument. That's n. We're passing y in this case. But where is this x? Well, in some sense, the x is who you are when you're running this multiply code. Right? And you want to multiply, n's numerator times your denominator, your numerator. Well, your numerator is right here, right? So something like, integer new numerator equals numerator times n's numerator. Right? That's the numerator of the result of this multiplication. And the denominator of the result is going to be your denominator times your argument's denominator, so n dot denominator. And so the result of this multiplication should be a new fraction whose numerator is this and whose denominator is that. And how do you make a fraction with those pieces? Call your constructor. So call a constructor with new num and new denom. Now this is the fraction that you want to return from the multiply function, and you can save that somewhere or you can just return it directly. And that's how all of those functions can work, right? You are calling x dot mul, so num and denom will be x dot num, x dot denom. If you called z dot mul, this would be z dot num, this would be z dot denom, right? These correspond to whatever object you use to call the multiply method. And then once you know the top and bottom for the thing you want to return, construct a fraction using, the constructor for the fraction class. The other thing to keep in mind is that, these things should be private. And so you'll get a compiler if you try to say, n.num, n.denom, but you're going to write a pair of accessors. You're going to have a getNum and a getDenom, and by calling those, you can get the numerator and denominator of your argument n. All right, so that's the basic setup for add, subtract, multiply, divide, and we're going to use that a lot throughout the course. Let's see. When done with that nan, can we see an example of returning that for an integer? You can't return an integer nan, it's always doubles. So the only time that you're asked to return the value double.nan is in the toDouble function. And toDouble returns a double, and double.nan is a valid double. Now the toString method returns a string, and if you're trying to return toString from a fraction that's not a number, just return the string NaN, 3 characters. When the fraction constructor is called with 2 ints, should we reduce inside that constructor or just reduce when adding, subtracting? It turns out if you reduce in your constructor, you make your life really easy, right? If every time you construct, you do your simplification to lowest common factor gets factored out, and you normalize top and bottom, and you check for division by 0 and so on, right? You never have to worry about it again, right? If I'm calling my constructor to make, the product of this, I know that the result of this construction will be a fraction that's already reduced, and I can just go ahead and return it. And then you don't have to worry about it. So yeah, definitely do that in the constructor. That's the best place to do it. All right. So why can't we just do z equals multiply x comma y? Because that's not object oriented, right? Now, where does this multiply function come from, right? If it's not part of x, where's multiply? It's just sitting in some global space with, 1,000 other functions. And, if this is our multiply for fractions, maybe we have to call it fraction underscore mul. Because maybe we've got a multiply method for imaginary numbers. And maybe we've got one for matrices. So it's about taking the functions, the code, and associating them with the objects that they work on, right? Otherwise, you end up what you have in C, which is, you can have one function called multiply, and that's it. So the effect is the same as calling a multiply with xy, but we want to make sure multiply is accessed as part of the fraction class. And that's not at all obvious, right? That's the whole deal of object-oriented methodology, and that's one of the big points of this assignment, is to get some practice doing that. All right, cool, good questions. Other ones? All right. Well, let's continue then. So let me open this up. All right. Let's start working on the pieces we're going to need for PA2. And I say this all the time, but it's especially critical here. hopefully people are already working on PA1 and making pretty serious attempts at it at this point. If you have not done object-oriented programming before, you really cannot start this Wednesday or Thursday. It really takes a lot of hammering against it and kind of rewiring parts of your brain to get your mind around objects and object-oriented design. And if you start this, you know, Wednesday or Thursday, you're going to be trying to write C and Java, and it's not going to be working. And you're going to go online, you're going to find out all kinds of weird things that you can kind of do, and you're going to end up with something that just feels not very good and doesn't help you with PA2 because you're not doing object-oriented programming. So you really want to be starting this, like, you know, already or as soon as possible if you haven't already started it, because you gotta grapple with these concepts and make peace with them, some sort of peace with them. Because in PA2 we're just going to go full bore objects. We're going to be you know, making linked lists that contain hashes, that contain strings and arrays of things and all sorts of stuff, and it's going to be really out of control in a really good, fantastic way, though, right? It's going to let us take all these powerful data structures and put them together to do some cool stuff. But that's not the place to be starting to wonder about, you know, how do I call a method in a class? This is the time we want to be thinking about that stuff. So keep working on it. All right, let's play with some concepts. So this is the way we've been making our main programs so far. Public static void main, string bracket bracket args. We don't do argc argv in Java. We do in C to get a hold of command line arguments. In Java, this is saying, call my main program, right? It's a function or a method. Pass it an array of strings. So the bracket bracket means an array. The type of things in the array are strings, and I'm just calling this args. You can call this anything that you want. It doesn't have to be args. But inside here, we can do the following. Let's print out args. Alright, so if I run main4, tells me args is something, right? Who knows what? Well, this is its representation of an array of strings, right? So that's not terribly informative. But let's print out args bracket 0, since I'm saying it's an array. Let's print out its first element. Main4. Well, if I do this, I get an error. And, you know, unlike sometimes with C, the error is pretty clear. Array index out of bounds, exception 0 at line 3 of Java, right here. There is no element 0 in my args array. Okay, but if I run this and I say this is a test, args bracket 0 is the word this. So this is simplicity compared to argc, argv, car star star, etc., right? When we run our Java program, this method main is called with an array of strings. The first element is the first thing I put after the name of the program. Second element is the second, and so on and so forth. If I were to look at the fourth element, right, and we still index from 0, so the fourth element will be args bracket 3. And so the fourth element is the word test. This is 0, 1, 2, test is element 3. Alright, so this is what the argv array does in C, except it's a pointer to a pointer because we don't have arrays and so on and so forth. So here it's just, you know, name of the argument, bracket, whatever index you want. Alright, how do I track additional files for Git? My large Git repo thing doesn't seem to be tracking PA1. So if you have your CSE223 submissions directory set up, and that's under Git control, make a directory PA1, put some stuff in there. If you do git add, git commit from that subdirectory, it should automatically put it under your Git repo, and then if you say git push origin master, it should push. And you can do that from that subdirectory. Just don't redo git init in those subdirectories. You're sitting inside one repository, so you do one git init originally in that top level. But now you can make subdirectories and you just keep adding and committing and pushing. Or you can do that from the top level. It should be the same. All right. So if I run this and I don't have 4 arguments, I get my out of bounds exception, right? It tells me I tried to use element 3 of this array, and that was larger than the size of the array. When I say top level, I mean your CSE223 submissions directory. You should never have to go onto the GitLab website except to set me up as a reporter, which you just do once, which presumably you've already done. But top level, I mean your CSE223 submissions directory on your Linux system. All right, so this is an array of strings. How do we know how many things are in that array? My screen's being weird. So unlike C, Java arrays come with other things associated with them. C is just a pointer to memory, so it could be, you know, any number of elements. In Java, there's a field called length. Anytime you have an array, there's a field called arrayname.length, and that tells you how many things are stored in the array. So if I run this with a single argument, it tells me the length is 1. If I run it with that, it tells me the length is 8, which means I have 8 things stored here on the command line. Let me turn this up. All right, how's that? No change, still dark. Dark as in hard to read, or dark as in completely blank? Interesting. How does this look for other people? Are you having trouble reading what's on the screen? Yeah, because it dimmed on me suddenly. Let me turn off my share and turn it back on. Alright, how's that? Okay. This happened last week too. For some reason, when I was screen sharing, it suddenly like dimmed out. Now it's burning my retinas, so that's good. Alright. And so all the usual stuff that we learned in 224, right? If we put stuff inside quotation marks, right, that becomes like a single argument. So we pass 3 strings to the main method. The first was ha ha, the second is this is a long set of, and the third was arguments. All right, so much more civilized in some ways than argc, argv, and very straightforward to use. So let's talk about arrays more generally. So that's the argument array, which is an array of strings. So this is how we would declare an array of 10 integers. We'd say int bracket bracket x equals new int bracket 10. Alright, so it doesn't do anything. So if we just do this, int bracket bracket x, that's a declaration. This is kind of like saying integer star x in C. It says x is going to be an array of integers. Okay, and that will compile just fine, but this will not. Right, if I try to print out the value of x bracket 0, it's going to give me an error and say, hey, I don't think that's been initialized. So we've said x is an array of integers, but we haven't basically told it how big that array is. And this x is not pointing to any particular location in memory. It's an uninitialized array. So we need to do the following. This sets aside space for x, and it makes x point to that. So now I can compile, and if I run this, right, it tells me x is 0. Well, I didn't give x bracket 0 a value, but it got initialized to 0. But initialize your variables anyway. But I could, you know, put a value in there. And this works exactly as you might hope. All right. So 2 things to declaring arrays of integers, for example. The declaration of it, and then the actual creation of the array. And you got to do both. You can do them in one line, right? Integer bracket x equals new int. Or you can do it in 2 pieces. All right. On the other hand, for general objects like fractions or rectangles or strings, this does not work. So let's make an array of strings ourselves. Okay, I'm going to make an array of 10 strings. And I'm going to print out the value of my first string, x bracket 0. Right, and it's going to tell me x bracket 0 is null. Right, just like if I make an array of integers and I don't initialize them, they start off at 0. If I make an array of objects and I don't initialize them, they start off as null. Okay, well, what does that mean? Null means basically it doesn't exist. So if I were to print out the length of x bracket 0, right, I can call the length method on this string and try to print out its length. Right, I'm going to get an exception. And this is analogous to something that we saw in C. There was some point in 222 where we created an array of pointers to nodes, and we had to allocate space for that array, so we had to call malloc, but then we had to call malloc again for each node that we actually wanted to be in that array, right? Same thing is happening here. This is saying X is going to be an array of strings. This is creating space for 10 references to 10 strings, but it's not actually creating the strings, right? We would need to do something like this. Right, we need to actually construct a string and have x bracket 0 be that string. And now it makes sense to say, you know, what's the length of x bracket 0? So length is probably a bad one for me to have picked on. Arrays always have this field called length, which is just a value. It's a field. It's not a method, so we don't put parentheses. But pretty much any other time that you see the word length, it's going to be a method in a class. And you know, if I look at the string class, and you look at the methods in there, there's a method called length. Right, and that's got parentheses because it's a field, but arrays are kind of an oddball. The field length, length, with no parentheses is just, you know, part of that object, kind of. Yeah, you're welcome. All right, so we can make arrays of objects, but it's kind of a two-step process, right? First create the array itself, and then you have to create the individual objects in the array when you want to use them, right? If you don't want to use them, you don't need to create them. All right. So this brings up the notion of primitives. So fractions, if you want a new fraction, you say fraction f equals new fraction. If you want a string, you say string s equals new string, and so on, right? But you'll see me do things like, you know, integer I equals 0, and I'm not using the keyword new. Or we could say, you know, character C equals X. And that's valid syntax. So we usually, you know, say things like everything in Java is a class. And that's almost completely true. It's true except for 8 things. There are 8 things which are called primitives. And primitives are not classes. They're kind of like, you know, special shortcuts to things that we use a lot of. And so 8 primitives: integer, character, float, double, byte, boolean, short and long. Right? These 8 things, we can declare a variable of that type just by saying, you know, character C, double X, whatever. And we can assign values to it with an equal sign and so on and so forth, and we don't need to use the new keyword. But a string, right, before we can use a string, we have to construct it with new string, or, you know, there's a shortcut for strings, which is just use a set of characters inside double quotes, and you can assign that to a string, and that constructs for you. You can use a byte basically as an 8-bit quantity, so you could say, you know, byte flag equals, maybe use 55 as a flag value, right? Any 8-byte value. The thing is, characters are not bytes, right? Characters are most likely Unicode, so they're 16, 24, or 32 bits, multiple bytes, right? So if you just want a short 8-bit piece of memory, you can use a byte. Strings are not primitives because more often than not, when you use a string, you're going to want to do things like check its length, convert it to uppercase, find the location of a character, stuff like that. Almost always when you use a string, you're going to want to do more than just give it a value, right? And maybe print it out. But integers, you know, more often than not, when we have an integer variable, we just want to store an integer value. We want to add, subtract, multiply, divide, compare it to other values, things like that. And those can all be handled without the use of a class. But there is an integer class, right? Integer is a full-on class in Java. And it's got, you know, a number of methods for counting how many 1 bits are inside. Yeah, same with double. We can find the maximum of 2 numbers. We can reverse the bits in an integer. You know, mirror image the bit pattern. We can convert it to a string so that we can print it, for example, and so on and so forth. Right? Doubles are a class, and so on and so forth. But, you know, a lot of times we just want an integer that holds, you know, a number, and we want to do arithmetic on it. And so we can use these primitives in that case. So if you make an array of primitives, you can get away with just saying something like, you know, car, bracket, bracket, A equals new car, bracket, 120. And now I have an array of 120 characters called A, and I can start storing things in the array and so on. And I don't have to construct the characters once I, you know, when I want to use them. So mostly this happens kind of under the radar, right? We don't even think about it. We're so used to saying integer I equals 0. We don't even think about the fact that we're not using the new keyword, right? So that's part of the idea of this, is to let us do what we're familiar with. All right, so other questions about this so far? So let's make an array of strings. And let's pass this to a function, okay? Passing arrays, very, very easy. Again, probably a lot easier than it is in C for most of us. So let's make a myPrint function, which takes the contents of a string, an array of strings, and prints it all out on one line, so that we have like a sentence or something. Ignore the fact that I'm putting the word static right here, but we'll talk about statics in a minute. I'll just call this A for arg. All right, so just making a funny little function here called myPrint that basically takes an array of strings, prints them out with spaces in between them, and then prints a period at the end, right? The reason I'm doing this is to show you how to pass and use arguments that are arrays. So x is an array of strings. I just pass it by its name, just like any other type of variable, right? Any other object, just put the name in here. In the function that's expecting an array of strings, what do I say? I just say string bracket bracket A. And that's all it needs. I don't have to pass its length because A contains its length. It has this field somewhere inside it that in this case is going to say there's 5 elements in this array. And I can access that field by saying, you know, array name.length. And so here I'm going to iterate over all of the strings. I'm going to print them out and get this thing to print a weird sentence for me. Right. So arrays work well in Java. They don't make you think too hard. We don't ever have to think in terms of memory locations or pointers or things like that. We don't have to think of this is a pointer to a section of memory that has a series of pointers stored in consecutive locations, each of which refers to a block of memory containing characters followed by a null terminator. That's what argv is, right? And that's why argv is kind of such a struggle for people in C, because it's all of this stuff we need to think about. In Java, it's just an array of strings. All right, clear enough? All right, let's talk about statics. Suppose I say, you know, fraction f equals new fraction 1 comma 2. So f is the fraction 1/2. Now inside your fraction class, you're going to write a series of methods. You might make a method called add, right? Which would let me say f.add, you know, g, where g is some other fraction. So all right, if I'm going to say f.add g, right, the f is here not just to say, you know, I want the add method from the fraction class, but to say I actually want the add method applied to the object f. In other words, we think of f as being an object of type fraction, which means that there is a numerator and a denominator associated with f, right? Those numerators and denominators, that's the thing that I want to use in my add method when I say, you know, new numerator equals numerator plus g dot numerator and so on, right? So this makes perfect sense to say that, you know, I'm going to add g to this fraction f. And if I didn't say f.add, if I just said add g, right, what would I be adding g to? I don't know. So I mean, I could pass it as another argument, but then add's just kind of an arbitrary function, right? So for this, you know, we definitely want to say, here's an object of type fraction. Use the add method from that class fraction to add f and g together. Okay, so that's what we've been doing so far. And this method is what we call an instance method. It's a method that we are running as part of an instance of a class. In this case, the fraction class, f is an instance of a fraction, right? It's a constructed fraction, and we're using this method as part of that instance. All right, so that's what we've been doing for a week now. Basically instance methods. Let me give you a hypothetical. you need to compute greatest common factor in order to reduce your fractions to simplest form, right? So somewhere in your fraction class, you might make yourself a method called GCD, which takes two numbers a, b, and returns the greatest common divisor of those numbers. You're not required to do this, but you might do that. It might make sense to you to have this piece of code. All right, well, supposing you write this piece of code and it's never been written before. This is like really cool stuff, right? And you realize, hey, you know what? This would be useful outside of the fraction class. There's other times when I want to find the greatest common divisor of two numbers. Maybe I'm doing cryptography, right? And I want to know if two things are relatively prime. So you might want to make this method available outside of the fraction class, right? To you know, something other than your internal use. Well, if I'm in, you know, some main program or something, and I want to find the GCD of two things, I could say GCD A comma B. But where does this method come from? It comes from the fraction class. With what we know so far, if I don't care at all about fractions, I just want to use your GCD method in your fraction class, here's what I would have to do. I would have to create a useless fraction, right? We'll call it fraction whatever. And we'd have to construct it. And then I could say, you know, whatever dot GCD. And I'm making this thing just so I have a way to get a hold of GCD. And that doesn't really make any sense. So what you can do is you can make GCD what's called a static. And if you do that, now you can get to your GCD method by saying the name of the class dot GCD A comma B. And now this is what we call a class method, or also what we call a static method. All right, so we have two types of methods. If you have a method that's going to be used as part of an instance of a class, that's an instance method. That's what we've been doing week 1. But if you have a method that you want to be able to execute without having to create an object first, we can make it a static method or a class method, and we can access it. Instead of putting the name of an object here, we put the name of the whole class. All right? There's no rhyme or reason to this beyond what I've just said. This is just the way that the developers of Java decided to make this available, right? But the important thing is there's two types of methods, instance methods and class methods, right? Instance methods, you need an instance of a class, and then you can use the method name. Class methods, you need the name of the class and then the method name. Okay, disturbing lack of questions coming in, but that's okay. Let's look at where this happens. Let's look at the math class. So math is a class, right? You can construct objects of type math and so on and so forth, but math is mostly a bunch of statics, right? There's a function called max. It takes two doubles and returns a double. Well, we don't want to construct an object of type math just so we can say object.math. So we could say uppercase math.max, and that will run this method. And this method takes two arguments and it returns a value. If we want the square root of a number, we can say math.squareRoot. And it takes a double and returns the square root of it. And there's instance methods and class methods. There's also instance and class fields. So the math class has two static fields, pi and e. And we can say uppercase M math.pi, and that gives us this magic number, which is pi. And if we say math.e, it gives us e. And the double class has a number of methods, and it also has some fields. One of those fields is NaN. And if you say uppercase D double dot NaN, you get back this number, which is the internal representation of not a number. All right, so these are statics. When you see the word static, it means that this is a field or a method that can be run using the name of the class rather than the name of an instance of the class. And most of the things in the double library are statics. Most of the things in the math library are statics. And so, for example, in the integer class, there's these methods like parse int. So parse int is a method. You hand it a string of characters and it gives you back an integer. Okay, this is what we used to use scanf for. But this will take a string and it gives you back an int. And it's a static method, so how do you access it? Uppercase I integer dot parse int. Yeah, okay, good question. So difference between the instance of a class and the class itself. So here's, class rectangle. And it's got fields, and it's got methods, and it's got constructors, and it's got documentation and all this sort of stuff, okay? This is the description of what a rectangle is. This is what I call the blueprint. All right? We can create objects, right, variables of type class. So we could create, a rectangle R1, and we could create a rectangle X, and we could create a rectangle, cool. And these things are objects, which are instances of this class rectangle. So this is the description of a rectangle. These are rectangles, right? So they're instances, they're constructed versions of, things that are constructed using this blueprint. So instance of a class is an object. Is it true that using double will be slower than double primitive? Not sure. I'm guessing, at least in some versions of the universe, yeah, probably using an uppercase double is going to be slower, depending on how the JVM is implemented. But it's a good question in general, whether that that would be different or not. Object is synonymous to instance. Yeah, basically. If you have an object, it's an instance. Usually when we use the word instance, we're talking about an instance of something. So yeah, class equals chairs, object equals this chair. That's a good example. The main program is a different story. Let's start tomorrow with that. Let's talk about the main program, because now that we've broken the ice on statics, we can talk about what exactly public static void main means. But the short answer is main program is a static method inside a class, right? When you write your code and you say public class main4 is a class. Main is a static method inside there, which means somebody could execute this main program by saying main4 dot main parentheses pass an argument. When you say Java main4, that's exactly what this command does. It looks inside this class main4 for a static method named main, and it executes it. So the main program is a method being run inside the class, usually without an object being involved. All right, so we can go through that tomorrow in some detail, and then I want to talk about doing input and output, and then we're going to start digging into some of the other classes that are available to us for linked lists and hashes and things like that. So we'll start layering up capabilities. All right, we are out of time. Have a good afternoon. I will see you tomorrow. Thank you.